So on the second part of lecture 22, we will try to solve logarithmic equations. Again, gonna utilize the one-to-one properties of the logarithmic functions. All right. So here again, the setup is that the base A has to be positive. A is different from 1. And you have this equation log of base A of x equal to log of base A of y. And through the one-to-one property, you can set x equal to 1. Okay. Now, technically, what you need to do is this. So you do log of base A of x equal to log of base A of y. Again, through one-to-one property, you can set x equal to y. I think you get that yesterday.
Same one?
Yeah, it's the same one. Another way to think about this is to apply the cancellation property. Cancellation property can happen when you have log function and exponential function put together, right? Composite of exponential functions and logarithmic function. So in this case, what you do is you have an exponential functions with the base a, right? With the same base of the log. So here's what you do. You do a log of base a of x equal to a log of base a of y. Wow. An exponential function and logarithmic functions kind of cancel out, and you're left with just x equal to y. So now we're going to utilize this approach to solve the solutions of logarithmic equations. So as I mentioned yesterday, when you deal with logarithmic function, you have to be careful because it requires you to find the domain of the logarithmic functions. So for instance, in this case, even though this is an equations, this is set up with two logarithmic functions, log of base a of x and log of base a of y. So therefore, the condition is that x is greater than 0 and y is that greater than 0. So those are the domain of the log function in this logarithmic equations. So that's what we're going to do. The procedure of finding the solution start with finding the domain of the function first. Okay. So in this case, you have two functions, log of base 3 of 5x minus 1 equal to log of base 3 equal of x plus 7. So you find the domain of the function. And then, okay, so let's find the domain. So here you have 5x minus 1 greater than 0, or 5x greater than 1, or you have x greater than 1 over 5. So this is the domain of the function on the left. And then x plus 7 greater than 0. This is the domain for the function on the right. What you need to do next is to find the domain that satisfies both functions. Sorry. So that is, you find the intersection between these two domains. So what is the x value such that it satisfies both functions? So again, find the intersections of these two domains. So one domain is that of x greater than 1/2. oh, sorry, 1/5. Right, so x greater than 1/5. So you get rid of this part. And 1 is x greater than -7. So you get rid of this part. Now, what is the intersection of these two domains of the two lines? So that you can find a domain or interval that satisfies two equations. So this is 1/5, right? So you just need this part of the line. So the total domain or the domain of that satisfy the two functions is going to be x greater than 1/5. If you choose x greater than -7, then when you consider, let's say, -6, it's not going to satisfy the first functions. For example, -3, it's not going to satisfy the first function. So therefore, x greater than 1/5 is going to be the case. So be careful here. So 1/5. All right, so that is the domain. So that is the very first step that you need to do. All right, so after finding the domain, now you can solve the equation. So the log has the same base, so you just set the functions x minus 1 equal to x plus 7. Here, then you have that 5x minus 1 equal to x plus 7. And then you can solve for x from here. So 5x minus x equal to 1 plus 7, or 4x equal to 8, or x equal to 2. So after you find the solutions, you go back and compare that with the domain. Is 2 greater than 1/5? Yes. So you conclude that the solution of the equation is x equal to 2. Since 2 is greater than 1/5, the solution is x equal to 2. Moving on to the next example. Any questions on the first example? Now for the second example, again, you have in the equations of the form log of 5x equal to log of 2x plus 9. The first step is to find the domain of the functions. So 5x greater than 0 or x is greater than 0. And you have 2x plus 9 greater than 0 or 2x greater than -9 or x is greater than -2 or 9/2. And then you have to combine these two domains together or find the intersection between the two domains. So that you come up with the domain that satisfies both functions. Okay. So you have x equal greater than 0 and x greater than -9/2. So this is -9/2. You want x greater than that, so you get rid of the left part of -9/2. And you have another line. This is 0. x greater than 0. So you get rid of this. And therefore, so the answer is x greater than 0. So for the domain of x greater than 0, satisfy both functions. So after finding the domain, you're going to set 5x equal to 2x plus 9 because the two logs are of the same basis. So then you get 5x equal to 2x plus 9, or this is 5x minus 2x equal to 9, or 3x equal to 9, or x equal to 3. And 3 is obviously greater than 0, so you conclude that the solutions is x equal to 3. So since x equal to 3 is greater than 0, the solution is x equal to 3. So the first two examples are easy. Now we're going to move on to number 3. So in number 3, as you can see, you have 3 different functions, 3 different log functions. First one is log of base 2 of x plus 1. Second one, log of base 2 of x minus 1. The third one is log of base 2 of 1. Now, again, before solving logarithmic equation, you need to find the domain of the functions. So you said x plus 1 greater than 0, x minus 2 greater than 0, 1 greater than 0. That is true. You don't have to write it down. You with me on that? All right, so just 2 domains. You have x plus 1 greater than 0, or x greater than -1, x minus 2 greater than 0, or x is greater than 2. Now combine these 2 domains together. So you have -1 here, right? X greater than -1. Here is 2, x greater than 2. So the intersection between these 2 domains is just x greater than 2. Okay. So now you can see 3 functions with the same base 2. Okay. But you cannot get rid of the log base 2 yet. What happened is on the left-hand side is the additions. What you do is you apply the product property plus a summation become multiplication. So log of base 2 of x plus 1 times x minus 2. You with me at that? Here you get that log of base 2 of x plus 1 times x minus 2 equal to log of base 2 of 1. So be careful with the notations. Right. It's okay for you to mess up everything at this point, but when you mess up, go back and look at the notation, look at how I present the problem, and write it that way. Okay? Make sure that after you combine in the 2 logs together, you drop the additions and drop the log base 2. So there is only one log base 2 left because you already combine x plus 1. Okay. Now log of base 2 are the same on both sides of the equations. Then you just set this product equal to 1. So x plus 1 times x minus 2 equal to 1. And technically, at this point, you're solving a quadratic equation. So first, expand them out. You have x squared minus 2x plus x minus 2 minus 1 equal to 0. Or this is x squared minus x minus 3 equal to 0. Well, this is awful. Can you do a quadratic, use a quadratic formula to find the solutions, please? All right, never mind. I have the solutions here. So if you do use the quadratic formula to solve these equations, you should have something like this. X is equal to positive 2.3 or x equal to negative 1.3. All right. So this is where the importance of the domain comes in. Right. So the domain is x greater than 2. You have two solutions here, 2.3 and negative 1.3. So you have to eliminate the negative value, negative 1.3 here. Okay. Say that. So this eliminates. So the solution is only x equal to 2.3. If for some reasons you have to eliminate two solutions here, then the conclusion is there is no solutions. Okay. Number 4. Any questions on number 3? Good. So number 4, again, first step, find the domain of the function. This is good for us. In this case, there's only one functions to find. So 3x minus 2 greater than 0, or 3x greater than 2, or x is greater than 2 over 3. So only one domain. All right. So the issue with this problem, it looks very naive. However, you don't have the log on the right-hand side of the equation. So what you do is you manipulate the right-hand side to make log of base 2 appear on the right. So now, this is where the second approach is very helpful. Here. For this equation, instead of setting x equal to y, directly arrive at this equations. What you do is you look at the base and you take a raised to the log of base a of x equal to a log of base a of y. Again, you cancellation property to arrive at this equation x equal to y. Okay, so we're going to utilize this approach. You look at the base and then raise that to the log function. So in this case, you have base 2. What you do is you do 2 raised to log of base 2 of 3x minus 2 equal to 2 square. Now the exponential functions, 2 right here, with a log of base 2, cancel out. But again, it's not correct to do. It's easy to understand. So this cancel out and you'll have with just 3x minus 2 on the left-hand side equal to 4. Good. So you have 3x minus 2 equal to 4. And you can solve for x from here. So 3x equal to 8. Or x is equal, 6. X equal to 2. And you say that since 2 is greater than 2/3, the solution is x equal to 2. Any questions? All right, moving on to number 5. So I'm going to do number 5 and I'm going to turn that to you to do number 6. Okay. So number 5, you have log of x plus log of x minus 3 equal to 1. So log in this case by itself, that means log of base 10. So you need to find the domain of the function first. So there are 2 domains to consider. X greater than 0 and x minus 3 greater than 0 or x greater than 3. Right. So here is 0. Get rid of this part. This is 3. You get rid of this part. Now the intersection between these 2 domains give you x greater than 3. The next step for number 5 is to combine the left-hand side together. So this is very similar to problem 3 that we just did. That you use or you apply the product property, turn this into log of x times x minus 3 equal to 1. Then you have log of x times x minus 3 equal to 1. So what you did from one step to another step is you apply the product property. So far, so good. Now you have log on the left-hand side. There's no log on the right-hand side. To get rid of the log on the left-hand side, what you do is look at the base. This is base 10, and you apply the exponential function of base on both sides of the equations. So you do 10 raised to log of x times x minus 3 equal to 10 to the first power. Then 10 with log of base 10 kind of cancel out and you're left with x times x minus 3 equal to 10. And you are solving the quadratic equation. So you do x squared minus 3x minus 10 equal to 0. You technically can factor this equations as x minus 7. Wow. X minus 5 times x plus 2 equal to 0. So you have x equal to 5 or x equal to negative 2. And now again, you go back, use this value to go back to the domain of the function of the equation to see that x has to be greater than 3. So you eliminate this solution. So you say that the solution is. So again, first of all, you need to find the domain of the functions. You have x greater than 0 and x greater than 1. Combine them together. You have the domain of the equations to be x greater than 1. Okay. Now, the next step is to combine the two terms on the left-hand side together. And you get log of 5x times x minus 1 equal to 2. So this is log of base 10. To get rid of the log, what you do is you do 10 raised to a log of 5x times x minus 1 equal to 10 squared. So log raised to log of base 10 cancel out, and you're left with 5x times x minus 1 equal to 100. Now divided both sides for 5. You get x times x minus 1 equal to 20. And again, at this point, technically, you're solving the quadratic equations. So you have x squared minus x minus 20 equal to 0. And you can factor this quadratic equations. You get x minus 5 times x plus 4 equal to 0. And you have 10x equal to 5 or x equal to negative 4. But because of the domain that we found at the beginning here, x greater than 1, you have to eliminate one of the solutions, one of the results. So eliminate negative 4. So the solution is x equal to 5. What time do we go? 1:20? 6 more minutes? Ugh. I don't want to work. Still want to get paid up. All right, one more problem. All right. So any questions on number 6? You follow? Yes. No, not always. It depends on the domain that you have. Okay. It just happened that it appeared that is always the negative number. No problem. Ask questions. Ask questions. Okay. I would rather you ask questions than not asking questions. Okay. Right. Okay, good. Number 6, we done. Any questions? Good. Any other questions? All right, let's move on to number 7. So number 7, again, you have 3 log functions. So you need to find the domain for the function. So 15x minus 5 greater than 0. 5 is always greater than 0, so you don't have to write it down. And then 2x greater than 0. 15x minus 5 greater than 0, or 15x greater than 5, or x is greater than 5 over 15, or x is greater than 1/3. Again, 5, you don't have to write it down. Right, 5 is always greater than 0. 2x greater than 0. So x is greater than 0. When you combine these two domains together, you have that x greater than 1/3 will be the domain of the equation. Now, the difference for number 7 compared to other problems that we have done is that on the left-hand side, you have two terms subtracted to one another. Okay. So you turn subtractions or difference into divisions or quotient. Then you have log of base 6 of 15x minus 5 divided by 5 equal to log of base 6 of 2x. So difference becomes quotient. And what we did is we use quotient property. Now you have log of base 6 on both sides of the equations. Just get rid of that, and you're left with 15x minus 5 over 5 equal to 2x. Now simplify the left-hand side a little bit, right? So on the numerator, 5 is the common factor. Yes.
Must have missed a part.
Because of the difference, the minus.
It's log 6, 15x minus 5 minus log 6, 5.
Oh,
Instead of the plus.
Focus here. Focus. I see. But you got it? Good? All right. We're all good up to this point? All right. So on the numerator, 5 is the common factor. Then you can get rid of the 5 in the denominator. Then you get 3x minus 1 equal to 2x, or 3x minus 2x equal to 1, or x is equal to 1. And since 1 is greater than 1/3, then that is the solutions. X equal to 1. So problem A, again, we try to solve this logarithmic equations. So you have 3 logarithmic functions in the equations. The first one is log of base 9 of x plus 6, then log of base 9 of x, then log of base 9 of 2. So you could like to first find the domain of these functions. Okay, so x plus 6 has to be greater than 0. X has to be greater than 0. 2 in this case obviously is greater than 0, so you don't have to put it down again. All right, so first x plus 6 greater than 0. This implies that x is greater than -6, and then x greater than 0. So now you need to combine these two domains together to form just one domain that satisfies all the equations. Sorry, all the functions in the equations. So that is x going to be greater than 0. Now,
After finding the domain, what you do is you manipulate the left-hand side of the equations to combine the two logs together using the quotient rule. So here I get that log of base 9 of x plus 6 over x equal to log of base 9 of 2. Again, what you just did is we use quotient property to rewrite a difference into a quotient. Okay. So now, because you have the same log of base 9 on both sides of the equations, we basically just set x plus 6 over x equal to 2. Now, it's very tempting to just cross multiply x on both sides of the equations. Technically, what you need to do is to just move everything to one side of the equations. That is x plus 6 over x minus 2 equal to 0. And then you find the common denominator of these two terms on the left. So that is x plus 6 over x minus 2x over x equal to 0. Now you have the same denominator, and you can combine the numerators together to give x plus 6 minus 2x divided by x equal to 0. Now, at this point, you have rational functions set at equal to 0. And when you go back to the previous lecture on rational function, what you do when you solve this type of problem is to just set the numerator equal to 0. So this implies that x plus 6 minus 2x equal to 0. Or you have 6 minus x equal to 0, or x is equal to 6. Now, when you have x equal to 6, you go back to the domain and you see that 6 is obviously greater than 0. So you conclude that x equal to 6 is the solutions of the equations. So since 6 greater than 0, the solutions is x equal to 6. All right, so I want to briefly talk about this particular setup. You may wonder why we don't just cross multiply x on both sides of the equation at this step. So what we actually try to do is a general approach in combining the fractions with a non-fraction term. Okay. And it's particularly useful when you actually try to solve for inequality, not equality in this case. When you have a non-linear inequality, it makes a lot of sense that you need to combine all the terms to one side of the equations. Not so much for equality that we are doing right now, but as a general terms, that is the approach that I want to follow. Okay, so I hope this helps. Again, in this lecture, we're talking about solving exponential equations and logarithmic equations. Exponential equation is a little bit too straightforward because you don't need to care about the domain of the functions. But when you get to logarithmic equation, you have to be very careful with finding the domain of the functions. And after you get the solutions, you need to go back and check if your solutions satisfy the domain or not. Okay, so that's it for me. Please let me know if you have any questions.